Good morning, students. So up to now I have learned the basic definitions of lines and angles and types of angles and pairs of angles, and now you are going to learn about the pair of lines. Different pair of lines you are going to learn in this session. First one is intersecting lines. All of you are aware of these intersecting lines in your previous classes also. So two lines are said to be intersecting if they have a point in common. If they have a point in common. The common point is called the point of intersection. This red color common point is called as the point of intersection. Here in this figure, line L is line L and line M are intersecting lines with O as the point of intersection. So this is the point of intersection. Okay. When two lines have a point as a common, then those two lines are called as the intersecting lines. Okay. For example, if there is no common point for given lines, then those two lines are called as the parallel lines. Okay, those two lines are called as the parallel lines. Here, observe here, if I move this, always these two lines have a common point and intersecting somewhere here like this. See the red point, it is moving. Okay, so that's why these two lines are called as the intersecting lines. Okay, and this point, this red color point, which is common to both the lines, is called the point of intersection. Okay. Next type of pairs of lines is second one is parallel lines. Of course, it is a parallel lines. So two lines are said to be parallel if they do not meet or intersect anywhere in the plane. Okay, so this is called as the plane here. This graph sheet itself is a plane here. Okay, in this plane, if you observe these two lines, they will not meet or intersect anywhere in the plane, even when extended infinitely in either direction. So here I am going to the left direction. Here, this is line A and line B. Even though you are going into the left side infinitely like this, they will not meet anywhere. Okay, if I go to the right side also, they will move like railway track. Okay, there will not be any intersection or there will not be any meeting in between them. Okay, they will not intersect anywhere. So these two lines are called as the parallel lines. If I move this, observe here, now also there is a distance, a perpendicular distance in between these two parallel lines, which is constant anywhere. If you observe here, the perpendicular distance between two parallel lines remains constant. Observe here, this is one division of distance is in between these two parallel lines. If you move anywhere in any direction, they will have a common perpendicular distance in between them. Okay, that is the property of parallel lines. If I move this to the upper side, here now these two lines have a common constant distance in between them, but perpendicular distance in between them, which is 3 units here. Okay, if A and B are two parallel lines, it is denoted by A parallel to B, and read it as A is parallel to B. Okay, you have to read it as A is parallel to B, and this symbol you have to use to show these two lines are parallel. A and B are parallel. You have to read it as A is parallel to B. Okay, so these lines are parallel lines. Now we are going to third pair of lines. Is actually this is not a pair of lines. It is under pair of lines we are learning. This is a transversal line. Okay, so if we take pair of lines like this, three lines more than two lines also you can take. Okay, and a line is intersecting two or more given lines in a plane at distinct points. Distinct point means different points is called a transversal. Observe here, this line is intersecting these three lines at three distinct points. I will change the color. So this red color line is called as a transversal. Why it is called as a transversal? This line is intersecting these three lines at three distinct points. Three different points it is intersecting. Why I am stressing the word distinct means, for example, if I move this here in between these two, where is exactly intersecting these two lines. Now this line is not called as the transversal of these two lines. So sometimes you forget this line. Okay, just we are taking only these two lines. If you observe, this line is intersecting these two lines at a common point. Now this line will become as the intersecting line. It is not a transversal now. Okay, now this line is not called as a transversal. Okay, when this line is called as a transversal, if this line intersect these two lines at two distinct points, like this, two distinct points should be there. Two different points it should intersect. Then only this red line, this line is called as the transversal line to the given two lines. Okay. So now this is the transversal of this line and this line and this line, for three lines. Okay. So in the figure A, T is the transversal, so you can indicate it as small t, and it intersects this line A, line B, respectively at A and B points. I have not shown the points actually. Here these you can take the point A and point B. At 2 points, at two distinct points it is intersecting. That's why this line is called as the transversal of these three lines. Okay, the lines may be parallel or may not be parallel also, like this. Okay, but that line should intersect the given lines at distinct points, distinct number of points. How many number of lines are there here? 3 lines. So it should intersect the 3 lines at 3 distinct points. That number should be equal to the number of lines. Wherever it is intersecting, that number is equal to the number of lines. 3 lines means this line should intersect all the 3 lines at 3 distinct points. Then only it is called as the transversal line. Okay. So now here if I take only these two lines are intersected by this line at 2 distinct points. 2 lines are intersected at 2 distinct points. That's why it is called as the transversal. If it is intersected like this at a single point, then this line is called as the intersecting line only, or concurrent line. These 3 lines are called as the concurrent lines also. Okay, one more name for that. So next one, we are going to fourth one, which is angles made by a transversal if it is intersecting 2 parallel lines. That is the important point here. If a transversal is intersecting 2 parallel lines, it will make some special angles. They have some properties also. Okay, if the 2 lines are intersecting by a transversal and those 2 lines are parallel lines, they will make some special angles, and they have some special names and special properties also. Okay, so that's why angles made by a transversal when it is intersecting 2 parallel lines only. So that is a special case. If it is not, if it is intersecting 2 lines like this, then these 2 lines are not parallel, and these properties also will not be applied to these lines. Okay, when these 2 lines are parallel to each other, then only these properties will apply. Okay, that's the important point you have to remember. So now the angles made by transversal, first one is the corresponding angles. Okay, corresponding angles. Corresponding means the angles which are formed by this transversal at two parallel lines at same places. Observe here, this transversal is forming an angle 1 and also it is forming angle 5. These two angles are forming at a same place. Okay, wherever this angle is forming angle 1 to these two lines, at the same place the angle 5 is also forming here. Okay, that's why angle 1 and angle 5 are corresponding angles to each other. Corresponding angles to each other. Like that, how many pairs they will made? 4 pairs of corresponding angles it will make. Okay. So now this angle 1 and angle 5 are the corresponding angles, and angle 2 and angle 6 are the corresponding angles, because these two are also forming at the same place. And angle 4 and angle 8 also corresponding angles. Angle 3 and angle 7 also called as the corresponding angles. Okay, what is the property of corresponding angles? Each pair of corresponding angles are equal. That's what the important point here. Each pair of corresponding angles are equal to each other. If you observe in this figure, this is forming 124.31. The corresponding angle of angle 5 is also have the same angle, which is 124.31 degrees. And if you take angle 2 and angle 6 are corresponding angles, and also they are also equal, 55.69. And angle 4 and angle 8 are also corresponding angles, and also they are also equal. Angle 3 and angle 7 also corresponding angles, they are also equal to each other. That's what the main property you have to remember here. Okay, and one more important point we have to remember here. Here, this transversal is intersecting the two parallel lines. We are telling that these two lines are parallel to each other. Initially, only we are telling that these two lines are parallel to each other. When this transversal is intersecting these two lines, these angles are forming, and already we explained here. Now the corresponding angles are equal to each other, and this property is used to prove whether the given two lines are parallel to each other. Whether the given two lines are parallel to each other or not, we will use this corresponding angles property. By using this property, you can tell that the given two lines are parallel to each other. If the given two lines are parallel to each other only, the corresponding angles are equal. If the given two lines are not parallel to each other, for example like this, then observe here, if it is then this angle is changed to the 134.12 if it is moved like this, and this is not moved, and this is actually 124.31 only. Observe here. Now also you can tell that these two angles are corresponding to each other only, because they are forming at the same place. Even though they are the corresponding angles, they are not equal to each other, because these two lines are not parallel to each other. So you can tell that by observing the angles, if the corresponding angles are not equal, then you can tell that directly the given two lines K and M are not parallel to each other. Okay, just by using that property, you can tell that the corresponding angles are not equal to each other. We can judge or justify that the given two lines, a pair of parallel lines, are not parallel to each other. Okay, like that you can prove. See here, once again I am resetting this. Again they are showing the same angles, since these two are parallel to each other. Okay, so like that, inversely or conversely, we can tell that if the corresponding angles are equal, when the transversal is intersecting two lines, then those two lines are called as the parallel lines. If they are not equal, then the given two lines are not parallel to each other. Okay, this property will be used when the problems are given that find that the given lines are parallel or not. like that question will be there. Okay, next one, alternate interior angles. Alternate interior angles. So before going to that, first we have to know what is the interior and exterior. These two are parallel lines, and in between these two parallel lines, this region is called as the interior of the parallel lines. Interior of the parallel lines. And the above of the parallel lines, all this region, and below the parallel lines, all this region, these two regions are called as the exterior regions. This is interior region. These two regions are called as the exterior regions. So from that we can identify that which one is the interior angle and which one is the exterior angle. The angles which are formed in between these two parallel lines are called as the interior angles. Primarily they are the interior angles. If they are alternate interior angles or not, that is another one. Primarily they are interior angles which are forming in between these two lines. Okay, if they are forming at the outside, which is shown in the upper figure, you see here these angles, angle 1 and angle 4 and angle 6 and angle 7, these four angles are exterior angles here. Okay, now what are the interior angles? Angle 2, angle 3, angle 8 and angle 5. These four angles are interior angles. Okay, now you know what are the interior angles and what are the exterior angles. So now we have to know what are the alternate interior angles. What are the alternate interior angles? Alternate means here opposite to the transversal. The angles formed opposite to the transversal line. So observe here angle 2 and angle 7 which are forming opposite to the transversal line. That's why, and they are existing in the interval. That's why these two angles which are angle 2 and angle 7 are called as the alternate interior angles. Also one more pair is there, angle 3 and angle 5. Okay, these two angles are forming opposite to the transversal line, and also they are existing in between these two parallel lines which is the interior of the parallel lines. That's why angle 2 and angle 7 are the one pair of alternate interior angles, and angle 3 and angle 5 also another pair of alternate interior angles. So now what is the property of these angles? Each pair of alternate interior angles are equal. Here also these are also equal, like corresponding angles. Corresponding angles also equal and alternate interior angles also equal. If you observe, this is 56.31, this is also 56.31, it's an alternate interior, and here this is 123.69, this is also 123.69. These two angles are also alternate interior angles, are equal to each other. If I adjust it as a right angle like this, observe here, now these angles became as, this is 90 degrees, this is also 90 degrees, and this is this red color angle, this is also 90 degrees, this is also 90 degrees. Okay, now here these two angles are alternate interior angles and also equal. Directly you can tell that. And these two angles are also alternate interior angles, and these two angles also equal to each other. The line may not be like a slant position like this. Okay, it may be in the straight position also like this. Okay, like this, to the left side, to the right side, or straight position also maybe will be there. Then also it is called as a transversal only. All the properties apply to that line also. Okay, it is not necessary to be as a slant line like this. So that we have to remember. So now these angles are alternate interior angles. Next one is, what is the next one? I'll show in the next slide. Over. Corresponding angles is over. Okay. Alternate exterior angles. alternate exterior angle. Already interior is over, exterior. The angles which will exist in the exterior region of the parallel lines, those angles are called exterior angles, and which are existing at the alternate or opposite sides of the transversal, then those angles are called as the alternate exterior angles. Okay, they will exist opposite to the transversal line, and also they will exist in the exterior region of the parallel lines. Okay, now what are the angles are existing like that? Here it is angle 1 and angle 7 are alternate exterior angles, and angle 4 and angle 5 here, sorry, angle 6, these two angles are also called as the alternate exterior angles. Okay, here 5 is not there. Yes, this is the 5, angle 5. So angle 4 and angle 6 and angle 1 and angle 7, these two pairs are called as the exterior, alternate exterior angles. So these angles also, each pair of alternate exterior angles are equal to each other. Corresponding angles also equal to each other. Alternate interior angles also equal to each other. Alternate exterior angles also equal to each other. So this is the property of alternate exterior angles. Next important type of angles which are formed by a transversal when it is intersecting the two parallel lines. Okay. Next, consecutive interior angles. Consecutive interior angles. Simply you can read it as co-interior angles also. So instead of reading this big word, you can read it as co-interior angles or consecutive interior angles. So what are the consecutive interior angles? Before that, they are interior angles. Okay, they are interior. That means those angles exist in the interior of these two parallel lines. Consecutive means what here? Which are existing to the same side of the transversal. Previously, those angles are existing at the opposite side. That's why they are called as the alternate angles. But these co-interior angles exist at the same side of the transversal. Maybe to the left side of transversal, and maybe to the right side of the transversal. Okay. So now what are the angles like that? Here angle 3 and angle 8 are existing at the same side of the transversal and also existing in the interior of the parallel lines. That's why these two angles, angle 3 and angle 8, are called as the co-interior angles, and also angle 2 and angle 5 are called as the co-interior angles. So what's the most important property of this one? The consecutive interior angles are supplementary to each other, or we can tell that the sum of the consecutive interior angles is always 180 degrees. Like that also we can tell the sum of the consecutive interior angles or co-interior angles is 180 degrees, or the consecutive interior angles are supplementary to each other. Okay, when will we call the given angles are supplementary to each other? If the sum of the given angles, two given angles, is 180 degrees, those two angles are called as the supplementary to each other. Okay, that is the most important property of these co-interior angles. So if you observe here, this is 123.69, this is 56.31. If you add these two angles, you will get 180 exactly. This also, this 123.69, and this is 56.31. If you add these two angles, you will get again 180 degrees. So if you see, if I move this like a perpendicular line here, you can easily understand here. If you observe here, these two angles are 90 degrees, these two angles are also 90 degrees. These two angles are co-interior and these two angles are co-interior, and if you observe, this is 90 plus 90, 180 degrees, then supplementary to each other. And these two also 90 plus 90. That's why these two angles are also supplementary to each other. Like that you can remember easily. Okay, if I move this like a slanted line, you can see these different angles. Okay. So these two angles are called co-interior angles. What is the main property of co-interior angles? The sum of the co-interior angles is always 180 degrees, means they are supplementary to each other. Okay, next one, here this is over exterior and consecutive interior angles. Next is consecutive exterior angles, which is the last type of angles which are formed by when the transversal is intersecting two parallel lines. Okay. So consecutive exterior, the name itself indicates that they exist in the exterior of the parallel lines and they will exist in the same side of the parallel lines also. Same side of the transversal line. So now these are existing at the same side of the transversal and also existing in the exterior of the parallel lines. Okay, that's why these two angles are called as these two pair of angles are called as the consecutive exterior angles. Which angles are forming like that? Angle 1 and angle 6 are the co-exterior angles, and also angle 4 and angle 7 also co-exterior angles which are existing at the same side. Co means consecutive, same side. Okay. So now here also same property applies. The sum of the two consecutive or co-exterior angles is always 180 degrees. Therefore, angle 1 plus angle 6 is also 180 degrees. Angle 4 plus angle 7 also equal to 180 degrees. Is it true or not? Once again, if I move it as a straight line or a perpendicular line, they are forming exactly 90 degrees. So 90 plus 90, 180. Here also 90 plus 90, 180. Okay, like that you can simply remember. Okay, if I move this like a slant line, okay, these angles also will form 180 degrees if we add them. Okay, these are the total types of angles which are formed by the transversal when it intersects two parallel lines. Okay, so next we are going to learn some problems based on these pairs of lines, the exercise 9b. Okay, so up to now I am going to end this session. In the next session I would like to explain the problems in the exercise 9b. Okay, good day to all of you.